Hi, my darling senior 2. I hope that you are fine. Today we will solve the questions on chapter 3, lesson 1. Let's start with the first one, the molecule of elements with electric configuration 1s2 to s2 2p6. 1s2, 2s2, 2p6 consists of dot atoms. It ends with 6 electrons. Now, if we distribute it Kl 2 and 2 here and 6 here, 8. Contain 8 electrons outermost energy level, so it completely filled. And the atom which contain 8 electrons outermost energy level called inactive atom. Inactive atom. And inactive gases or inert gases consists of one single atom. The molecule of it consists of one single atom. So we'll choose number A. Another one, what are the number of unpaired electrons in N7? Negative 3. Nitrogen 7, negative 3. Nitrogen negative 3 means it gained 3 electrons because it's negative ion, so it gained. Okay. First, let's distribute it N7 to 5. Okay. So in it around contains around 5 electrons. 1, 2, 3, 4, 5. Now it gain 3 electrons, so 1 here and 1 here and 1 here. Now this paired and this paired. So there is no unpaired electrons, so it will be 0. Number A. Another one, which following element of group 2A forms compound which show the properties of covalent compound. First, as metallic character increase, the ability of element to form ionic compounds increase. But as the metallic character decrease, the ability of element to form covalent compounds increase. Take this information as you studied it, okay? Now, element of group 2A, if you look at the periodic table, you can find it beryllium, magnesium, calcium, selenium. Okay. And from the first term, as you know, as we go from up to down, the metallic character increase. So the least metallic character in this group will be beryllium. So beryllium has least metallic character, and as metallic character decreases, the ability of covalent compounds increase. So we'll choose beryllium, number A. Number A. Another one, which of the following values represent a difference in electronegativity in good electric conductor compounds? A good electric conductor means that it is ionic compound. An ionic compound must, the electronegativity, the difference must, and the ionic compound must have difference in electronegativity between its atom not less than 1.7. Not less than 1.7, okay? So we'll choose any number more than 1.7, so we'll choose 2.1 because any compound must have difference in electronegativity between its atoms more than 1.7, and all ionic compounds are good conductor of electricity. Which of the elements forming opposite compound has higher partial negative charge? Chlorine or bromine or iodine or fluorine. Ability of atom to form a higher negative charge, the smallest size, which can attract the electrons toward it, okay? So when electron attracted to it, it will gain negative charge. The smallest size here is fluorine. So fluorine is the has higher partial negative charge. The opposite figure represents dot compounds, ionic or polar. Or let's look at it. First, Y contain around it 2, 4, 6, 7. Y contains 7 electrons. So Y, the outermost of it contains 7 electrons. So Y non-metal. Z containing 2, 3, 4, 5 contain 5 electrons, and also Z non-metal because it contains 5 electrons outermost energy level. So the bond between and as you know, bond between non-metals will be covalent, not ionic. So we want to choose ionic. but polar covalent or pure covalent. Pure must between two similar atoms. Two similar atoms, but they are different and more than two atoms. So let's choose polar covalent. Polar covalent. Let's take another one. Which following compound is more polar? Okay. As you know, as difference electronegativity between elements increase, the polarity increase. Gives you the value of electronegativity of H and N and O and F. So if you try HF, you can find in HF, H is 2.1 and F is 4. So difference in electronegativity between them will be 1.9, and this is biggest change in electronegativity, or biggest difference in electronegativity. So the most polar one is HF. Another one, which of the following choice represent hydrogen cyanide HCN? Which of the following represent hydrogen cyanide? First, it's, as you know, hydrogen contain 1 electron's outermost energy level, carbon contain 4, nitrogen contain 5. Because C6, if you distribute it to 4, so it has 4 electrons, like that, N7 to 5. So it has 5 electrons outermost energy level. Let's draw Lewis diagram. According to Lewis diagram, HCN, each atom must have 8 electrons around it, okay? But for hydrogen, because it have only 1 energy level K, so if we draw it, it contain 1 electron here. And for carbon, it must have 8 electrons also, but here it have 4, okay? So let's draw 4 electrons of carbon. 1, 2, 3, 4. Because it will form triple bonds with nitrogen. And for nitrogen also, it must have 5. 1, 2, 3, 4, 5. So now bond will be formed. Bond will form it between hydrogen and carbon. And the 3 bonds will form it between C and N. Always a carbon atom tend to form 4 bonds. So it has 1 here and 3 here. Okay, but now we have 1 lone pair. 1 lone pair for nitrogen, but have no lone pair in case of hydrogen or carbon. We have only lone pair in case of nitrogen. So number B, nitrogen atom N7 has 1 lone pair of electron, but carbon, if you try to read the number A, carbon atom C6 has 1 lone pair. No, it has no lone pair. All of them are paired. Nitrogen only has 1 lone pair. If you have any more questions, please send a message to me. Thank you.